In this video, I will introduce central tendency, which is the center of data points. And you can find the center of data points by finding the mean, median, mode, and range, which we will go over. And then I will introduce the stem and leaf, and the box and whisker plot, percentiles, and the mean absolute deviation. So yeah, let's talk about central tendency. So central tendency measures the center of data points, and the best way to find the values is calculate mean, median, mode. So this lecture is an introduction to statistics course. So it's essential in statistics. Statistic is the collection of data and information that has things in common. Central tendency describes a specific point in a set of data that tells you where the center lies in a given set of numbers. The most common measure of central tendency are mean, median, and mode. So let's talk about mean. So you've probably heard of that many times. Mean pretty much means average. So to find the mean, you divide the sum of set of numbers by the number of elements in a set. So basically, you add up all the numbers and divide it by the total amount of numbers, right? So there's two ways you can describe mean. Average. You could do x and then this straight line. That means average. So that is a sample mean. And then you also have a mu, this little u, it's called mu, and that is called a population mean. So I think either way works. The median is basically terms that falls directly in the middle of the set of numbers. So you would always make sure the numbers are first in order from least to greatest, and then you pick the number in the middle. Note, uh, if your total amount of numbers are even, so if your total amount of numbers are even, what you do is you take the average of the two numbers. You take the average of the two middle numbers. And then if your total amount of numbers are odd, it's the number right in the middle. Okay. So yeah, that's median. And then mode is the most popular term that appears the most frequent in a set of data. Range, so if you ever hear the word range, it's the difference from the greatest number to the least value. So basically the largest number minus the smallest number. And percentile, the value below which a percentage of data falls. Quartile, so this is kind of important when we're doing the box and whisker. The values that divide a list of numbers into quarters for equal parts. I'll explain that. So this could be quartile 1, quartile 2, quartile 3. I'll explain that more in the box and whisker. So now let's start with an example. So I went over all these terms. Let's actually find them. So example 1 says find the mean, median, mode, and range. Okay. So step 1, what I would always make sure is make sure are in an ascending order from small to least. Okay, so that's the first step I would do. Make sure the numbers are in ascending order from small to largest. So are they? Not quite. So let's put it in order. So by the way, how many numbers are there? There's 1, 2, 3, 4, 5, 6. There's 6 numbers. So to find the mean, you can say x and then straight line. So hold on, let me put it in order first. That would help. So smallest number is 12. Next one, the next smallest number is 14, 17, 18, 18. Yes, and if it repeats, do not ignore it. Still write it out. And 23. So now we can find the mean. So x and then the straight line means mean. Basically, you add up all the numbers. And divide it all by 6. Because there's a total amount of 6 numbers, right? So that is going to be 102 over 6, which is 17. Okay. Now let's find the median. So median, just make sure you got to make sure you're in order. So we have, I'll write it out again, 12, 14, 17, 18, 18, and 23. So how many, median is the number right in the middle, but we said that if this wasn't even, so how many numbers do we have? We have a total of 6, right? 6 is technically even. So what you have to do is take the average of the two numbers. So the average, I'm going to take the average between 17 because those two numbers are right in the middle. And if you're not sure, what you do is, so on the left of 17, there's 1, 2, two numbers to the left. And then on the right of 18, there's two numbers. These numbers has to be the same, right? So the median is going to be 17 plus 18 divided by 2, which is 17.5. Okay, now let's do the mode. So the mode is the number that occurs most often, so I think it's 18. Yeah, 18 occurs the most often. And then let's do the range. So the range is the largest minus the smallest, and my largest is 23, minus my smallest, which is 12, and then 23 minus 12 is 11. I think not too bad, right? So let's move on to example 2. So example 2, the same direction, find mean, median, mode. And we have, these are numbers, 68, 78, 76, etc. So let's quickly count how much numbers we have. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is even. So now what I'm going to do is put it in order. Is it in order? I think it is in order. 68, 70, 76. Yes, everything is in order. So to find the average, let's find the average or the mean. So you add up all the numbers. All over 10. So that's going to be 803 divided by 10, which is 80.3. Okay, so your average is 80.3. Okay, now let's find the median. So let me rewrite the numbers again. Actually, yeah, let me rewrite the numbers again. So it's 68, 70, 76, 82, 82, 84, 85, 87, 88. So there's a total of 10 numbers. Now we got to take the, because 10 is even, you take the number between right in the middle. So I think we got to take the average between 82 and 82 because there's 1, 2, 3, 4, 1, 2, 3, 4. So there's a total of 4 yeah, 1, 2, 3, 4, 1, 2, 3, 4. So the median, uh, even though these are numbers are the same, but if they were two different numbers, you still got to take the average of these two, right? But because these numbers are the same, the average of 82 is going to be 82. Okay, so that is our median. Mode, we have a mode? I believe so. I think 82 is the one that occurs most often. So our mode is going to be 82. Okay, the range. So range is large minus small. So my largest number is 88 minus my smaller number is 68, just 20. Okay, let's move on to example 3. So example 3, same direction, find mean, median, mode, and range. So uh, let's take the average. And I think the numbers are already in order. 1, 2, 3, 3, 4, 5, 5, 9. They're in order. Good. So my average is going to be 1 plus 2 plus 3 plus 3 plus 4 divided by the total amount of numbers. So there's 1, 2, 3, 4, 5, 6, 7, 8. Yes, there's a total of 8 numbers. So, and when we put that in the calculator, you should get 32 over 8, which is 4. So your average is 4. Okay, let's find the median. Uh, I'll just rewrite the numbers again, but it is in order, so that's good. How many numbers are there? There's a total of 8. So 8 is even, so I think you got to take the average between 3 and 4. So it's going to be 3 plus 4, and then 4 plus 3 is, so that's going to be 3.5. So your median is 3.5. Mode. So I think we have two modes. There's 3 that occurs twice, and then 5 that occurs twice. So I think our mode is 3 and 5. And then the range is largest minus smallest. So my largest is 9 minus my smallest, which is 8. Okay. Okay, so we went over mean, median, mode, and range. Now let's talk about frequency, distribution, line plot, outliers. So frequency distribution shows the number of instances of various outcomes in a sample. A line plot organizes data on a horizontal line, which each set is denoted by an X over the corresponding value. The number of X above each number indicates how many times it occurs. So we're going to go over box and whisker plot. So that is a plot. Outliers basically are values that are substantially different from the rest of the data set. They occur at the end if they occur at the ends if they occur. So an outlier is a number that's way off. It's either really small or really large. And yeah, you can definitely spot it out. So let's look at example 5. We have goal scores in 10 games. Let's kind of make a frequency table. And then let's make a line plot. So a frequency table. So here, I'll show you. So let's put goals. So this is goals scored in 10 games. So you could put goals here. And then you could put frequency here. So goals, there are 1, 2, 3, 4, and then for 1, there was a frequency of 2, right? Here and here. So you put a 2 here. For the number 2, there was a total of 1, 2, 3, 4. So 2, you're going to put 4. For 3, you're going to put 1, 2. And then 4, there is a total of 1. Yep, so this is a frequency table. Okay, and then let's make a line plot. How do you make a line plot? So on the definition of plot is line plot organizes the data in a horizontal line on which each set is denoted by an x over the corresponding value. The number of x above each number indicates how many times it occurs. So it would look something like this. So I don't think there's a vertical axis, just a horizontal axis. Okay, so here's 1, here's 2, here's 3, and here's 4. So on 1, we said there was a frequency of 2, so you're going to put two x's. And then on 2, there was a total of 4 frequencies, so you put 4 x's. And then 3, there's 2. And then 4, there's only 1 frequency. So that is how you make a line plot. This is the x. There's no y. Okay, let's move on to example 6. So example 6, ages of people working in an office building. We have 30, 40, 34, 40, 40, 40, 40, 40, 41, 41, 21, 30, 46, 46, 79. So let's, just like example 5, let's make frequency table and a line plot. So for the table, we'll do ages here. And then frequency here. Okay, so ages 21. This would have a frequency of 1. Ages 30. That would have a frequency of 2. 34. That has a frequency of 1. 40. It has a frequency of 4. 41. That has a frequency of 2. 46, that is a frequency of 2. And then 79 has a frequency of 1. Okay. So this is a frequency table. Now let's do the line plot. Okay. So if you look at our numbers, our ages, our smallest ages would be like 30, or no, 20. And then our highest is like in the 70s, right? 79. So what I'll do is I'll start at 20s and go by 30, like go by 10s. So what I mean is like start at 20, this next would be 30, 40, 50, 60, 70, and 80. Okay, so look at 21. Here's 21, and that has a frequency of 1. So here, this would be like 21 right here. The next one is 30. Right here, this has a frequency of 2, so put 2 X marks. The next one is 34. So here's 35, so 34 should be right there, and that has a frequency of 1. And the next one is 40 with a frequency of 4. 1, 2, 3, 4. 41 has a frequency of 2. Here's 40, here's 41. There's a frequency of 2. 46. 46 has a frequency of 2. And then 79 has a frequency of 1. 79. Okay. By the way, do you see any outliers? I do. I see an outlier. It goes from 20, 30, 40, and then it stops at 79. So 79 would be the outlier, right? Good. Okay, now let's talk about stem and leaf plot. So stem and leaf, a format that splits 2 or 3-digit numbers in half, with the stem as the tens or hundreds and the leaf as the ones digits. So here I'll show you. So on example 7 says create a stem and leaf. So yeah, this is on order. This is not 618, this is 68. And so our numbers goes from 60s to 80s. So I think we're going to go by tens. So this is how I would create it. Here's your stem. Here's your leaf. So we're going to replace anything with the 60s. So we only have numbers in the 60s. That would be 68. We're going to replace that with this on the stem. We're going to replace that with 6. And since we're going by tens, the leaf will be 8. Okay. Now, what about 70s? We have two numbers that's involved in the 70s. We have 70 and 76. And they're both by tens. So we're going to put a 7 here. And then for the 70, we're going to put the leaf as a 0. And then for the 76 number, we're going to put the leaf as 6. Okay. And then we have 80s. We have quite a few 80s. We have 81, 82, 84. And 80s are in the tens. So we're going to put an 8 here. And we have an 82. So you're going to put, oh, no, we have an 81. So you're going to put a 1. And then we have an 82 and 82. Just because it repeats, you still have to rewrite it. So we're going to put a leaf of 2. 2. And then 84. That'd be 4, 5, 7, and 8. Okay. That's pretty much how you make a stem and leaf. I don't think there's any commas. So ignore the commas. Just put the numbers. Okay. Let's move on to example 8. Example 8 says create a stem and leaf of 100, 105, 110, 114, 121. Yeah, all those numbers. I think it would be easier if it's in order. That's what I would first check. And I think it is in order: 100, 105, 110, 114, etc. So the leaf is a little keynote. The leaf is always a single digit. Okay. So let's make our stem and leaf. And because these numbers are in order, so let's start with the 100. There's one, two, three, four numbers that involves in the hundreds. This time we're going to use, because this is two places, we're going to replace this for the 100, we're going to replace the scheme as 10, not 1. And then for the 100, we're going to replace the leaf with 0. So yeah, the leaf is always a single digit. So this is why we put a 10 here. And then I'm going to put a 5. And okay, so we're going to stop here, and then we're going to do the 110 and 114 separately. So yeah, since the leaf is always single digit, for the 110, we're going to put 11 here, and then put a 0 here, and then we have another 11 at 1114, so you're going to put a 4 there. Okay. And what about 121? That would be 12. And you'll put a 1 here, 5, there's no commas, 5, and then another number for 120s are 125. So you're going to put, 128. Okay, 136. So this would be 13. And then you're going to put a leaf for 6. 142, it's going to be 14. And then put a 2 here. And then 144, so you're going to put a 4 there. Finally, 150, so you're going to put 15. And then put a 0 here. And 4 there. Okay, so you just have to remember the leaf is always a single digit. So the steam might have to for the steam, you might have to put more digits, right? Okay, so that is stem and leaf. Now let's do the fun part, the box and whisker plot. So box and whisker plot is designed to convey the central tendency and only shows certain statistics rather than all the data and uses. So what we need is a minimum, maximum values, and the greatest to least. We also need the median and quartile, we'll need quartile 1, quartile 2, and I'll show, yeah. So I'll explain what quartiles. So we need median and quartiles to display the variability spread in the data set. So here I'll explain how to create. So example 8 says create a box and whisker plot for the amount of Pokemon cards of 15 different children. So what I will do first is step 1, make sure place it in order from least to greatest. Okay, so that's what I'm going to do. It's not in order this time. So what is my smallest number? I think it's, okay, 18, 27, 34, 52. So how many numbers are there? There is a total of 3, 4, 9, 10, 11, 12, 13, 14, 15. There's a total of 15 numbers, which is technically what? Odd, right? 15 is odd. So what I will do next is Step 2, find the median. So median is also called the second quartile, or Q2. So because 15, the total numbers out there is 15, the middle, I think the number right smack in the middle is 68. So if you're not sure, count how many numbers to the left and count how many numbers to the right. If they're the same amount, then that's the middle number. So there's 1, 2, 3, 4, 5, 6, 7. Over here, this is 1, 2, 3, 4, 5, 6, 7. Okay, so they're the same. That means 68 is definitely the median, or Q2. Okay, step 3, lower quartile, or Q1. So it's basically the median of the lower quartile. So what I mean is, this would be the lower quartile, and then what you do is pick the median. So there's a total of how many numbers? This is the lower quartile, and then you pick the number right in the middle. So there's a total 1, 2, 3, 4, 5, 6, 7. There's 7 numbers, right? So 7 is odd, so the median would be 52, or Q1 will be 52. Okay, and then the next one is the upper quartile. Also known as Q3, which is basically the median of the upper group. So here, this is what I mean. So this would be the upper quartile, and you pick the number right in the middle. So there's a total of 7. 1, 2, 3, 4, 5, 6, 7. So the upper quartile will be 87. So your quartile 3 will be 87. Okay, we need all that to create a box and whisker. So this is how I would create it. So so our minimum was, what was our minimum? 18. And then our quartile 1, our Q1. What was Q1? The lower quartile, 52. So we could put 52 here. And then quartile 2 was 68. And then quartile 3 was 87. And then our maximum number was 100. Okay, so you're going to put a little dot on your minimum. So 18 is your min, 52 is your Q1, 68 is your Q2, also your median, 87 is Q3, and 100 is your max. It's going to look like this. Dot here, and then another dot on, oops, and then another dot on 68, and then another dot on 87, and then another dot on 100. Okay, so you put a little line here, and then you're going to make a little box from quartile 1. and then you're going to connect it with quartile 3. And then you're going to put a little line right here. Okay, so this is quartile 1, quartile 2, and quartile 3. Just make sure these numbers are even. So we went from 18 to 52. Just be careful with the numbers. Just make sure they look okay, like they're not too far apart. Yeah, that is a typical box and whisker plot. Oh, don't forget, there's a straight line that connects quartile 3 with the max. Okay, let's move on to example 9. So example 9 says, find the mean and median mode of the data set and make a frequency distribution table, line plot, stem and leaf, and box and whisker. So our numbers are 11, 12, 12, 14, 15, 15, 16, 20, 20, 29, 29, and we got to find all of this, mean, median, mode, and a frequency distribution table, line plot, stem and leaf, and box and whisker. So the good news is it is already in order. So I'm going to find the mean. So basically, you just add up all the numbers. Divided by the total amount of numbers. So the total amount of numbers looks like there's 1, 2, 5, 6, 7, 8, 11. So your mean, you add up all the numerator, that's 193, divided by 11, which is 17.27. Okay. Then I would find the median. So the median, let's see, there is a total of 11 numbers, so 11 is odd. So you pick the number right in the middle. So it's going to be, here, let me write out the numbers again. It is in order. That's good. So there's a total number. So I think the median would be 15. So if you're not sure, count how many numbers from the left of 15. So there's 1, 2, 3, 4, 5. There's 5. And then on the right side of 15, there's 1, 2, 3, 4, 5. So there's 5. That means that is right in the middle. Okay, so your median is definitely 15. Okay, step 3 on the mode. So the mode is the number that occurs most often, which is I think we have several numbers that's most often. So a mode could be 12, 15, 20, and 29. Okay, so we found the mean, median, mode of the data. Now we're going to make a frequency distribution table. Okay, so let's make a frequency table. We could put value here and frequency there. Okay, so let's start with number 11. It looks like it only occurred once. We put 1 here. Number 12 looks like it occurred twice, so you could put 2 there. 14 occurs once. 15 occurs twice. 16 occurs once. 20 occurs twice. 29 occurs twice. Okay, so that is your frequency table. Now let's do a line plot. Plot here. Okay, so we have 11, 12, 14. So 11, it only occurred once. So you're going to put 1x. 12, it occurs twice. So you put 2 x's. 14 occurred once. 15 twice. 16 once. 20 twice. 29 twice. Okay, so that is a line plot, which make a stem and leaf and box and whisker. And I am running out of space, so I'm going to move it to the right. So 6, we are creating a stem and leaf. So yeah. So yeah, let's look at 11. So remember the leaf can be only a single digit. So for 11, we're just going to use 1 and then put a leaf of 1. 12, we're going to put 2, and there's a lot of, so it would be 2, 4, or twice 2, then 4, 5, 5, and then also 6. And then for the 20s, you put a 2 here. You have 20, 20, so put 0, 0, and 9, and 9. Okay, so that is a stem leaf. Now let's go ahead and make the last one, the box and whisker. So what we need is A, for the box and whisker, we need the median, or that's also quartile 2, just 15. B, we need the lower median, or Q1, which is, I believe it's 12, because so 15 is right in the middle. This is the lower quartile, and then there's 1, 2, 3, 4, 5. So I think, wait, 1, 2, 3, 4, 5. 5 is odd, so I think it is 12. Yeah, there's 2 numbers here, 2 numbers there, and then this would be the upper. And there's a total of 1, 2, 3, 4, 5. So the upper should be 20, or quartile 3. Okay, so quartile 1, I mean the lower median quartile 1 is 12, and the upper median or quartile 3 is also 20. Okay, so now let's create our box and whiskers. So we have put 5 here. Let's go by fives. Yeah, let's go by 5. So this would be 5, 10, 15, 20, 25, 30. Let's see. 11. So here's 11. Wait, so what do we our minimum, what's our minimum? That's what we need. Minimum is 11. So this could be 11. So put a little dot there. And then 12 is quartile 2. So you put a little dot there. 15 is our median. Put a little dot there. 20 is quartile 3. So put a dot there. And then what's our max? Our max is 29. So put a little dot there. Okay. And then so 12 is quartile 1, so you're going to put a little box here. And then for 20, put a little box there. And then put a little straight line here. And then put a line here. This is like your whisker. This is your box. And then connect this line with this. And this is your other whisker. This is your box. So 12 is quartile 1. 15 is your median, which is quartile 2. And 20 is quartile 3. Okay. So that's how you create a box and whisker plot. Okay, let's move on and let's talk about percentiles. Okay, percentiles. So let's just do straight an example. So example says find the percentile for the given data. We have 41, 54, 61, 65, 70, 73, 74, and all those numbers. So what I would do, and they want you to find, they want you to, this is part of a problem. It says find the 65th percentile. Okay, so what I would do is, or yeah, right here, make sure it's from least to greatest. That's the first thing I would do. And how many total numbers are there? That's the next thing I would find out. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. I think, no, there's actually 20. I counted it wrong. Did I miss some numbers? Yeah, there's 20 numbers. So to find the 65th percentile, it's a total of numbers. So 20 times 65%. So that's going to be 20, and then multiply 65% can be also expressed as a decimal as 0.65, and that equals 13. So what is 13th? What is the 13th number? 13th number is 82. Yes. So 82 is the 13th number. So what that means is, so 82 is a 65th percentile. That means 13 values, 13 values fall at or below 82. Okay, so that's what it really means. Okay, so first, make sure it's in order, because if it's not, it'll be wrong. And then count how many total numbers you have. And since we're finding the 65, it's going to be the total of numbers, 20 times the percentage. And then I got 13. Look at the numbers. 13 is 82. It just means that 82 is a 65 percentile. That means 13 values fall at or below 82. Uh, yeah. Part B says find the 55th percentile. So there's still a total of 20 numbers and then multiply it by 55%. So that's going to be 20 times 0.55, and that gives you 11. And if you look at your numbers, 11 is the 11th term is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I know why. I should have, there should be 79 here. That's why I was a bit off. Yeah. So the 11th term is 79. So what that means is, so 79 is the 55th percentile. That means 11 values fall at or below 79. That's it. Okay, what about C, the 93rd? So it's still number 20, and then 93% can be expressed as 0.93, and that is 18.6. So if you have a decimal, you do have to round because you can't go 0.6. So 18.6 rounded to a whole number would be 19. Yeah, so note. Percentiles cannot have decimal. You're going to need to round. So yeah, it should be 19, not 90. So if you look at the 19 term, it is 98. Yes. So this is the 19th term. So that means, so 98 is the 93rd. Nineteen values fall at or below 98. Okay, let's talk about, so we did percentiles. Now let's go over mean absolute deviation. So mean absolute deviation, we know that mean means average. We know absolute means absolute value. And then we know that deviation means distance away from the mean. Okay. So mean absolute deviation, or also known as MAD, is a statistical technique used to see if the data is spread out or not. It depends. It's basically how far on average of all the values are from the mean. So here's the formula for MAD. If you've seen this in pre-calculus, this is the summation, and the I stands for your initial value, the N stands for the endpoint, and then it's the absolute value of X minus, and you've seen this symbol already, that means average, all over N, meaning the total number of numbers, right? So you can also express it like this, and yeah, you can also express it as the absolute value of X minus mu, or that mu means average, all over the total amount of numbers. And then the summation means sum. So you've probably seen this before, sigma, stop, sum. So this example, what would be the mean? Find the mean absolute deviation. Or let's do this one real quick. So I kind of did this one already. We start at the first term, and then we end at the fifth term. Yeah, so it's 2, 4, 6, 8, 10. Summation means it adds up all the numbers. That's all it means. Okay, now this example says find the mean absolute deviation. We have 78, 91, 456, 673, 111, 381, and 21. This time it doesn't matter if it's in order. You just need to know the formula, which is the absolute value of X minus mu. Okay. So let's do that. So let's kind of make a table. Actually, let's find the average. What is the average? So the average is going to be, we don't have to put it in order to find the average. You just add up all the numbers. Divided by the total amount of numbers. So there's a total of 7. And you get about 258.7. So yeah, let's kind of make a table. So here on the X, it's X, and then over here, it's going to be the absolute value of X minus the average absolute value. So 78, and then this is going to be the absolute value of 78 minus the average, which is 258.7. If you put this in the calculator, it should give you an absolute value of negative 180.7. And we know that taking the absolute value of the number always becomes positive. It's 180.7. The next number is 91. So it's going to be 91 minus the average. That's going to be absolute value of negative 167.7, which is 167.7. Okay, next one is 456. So that's going to be 456 minus 258.7, and that is going to be, when you do the absolute value, it's going to be 197.3. And then the next one is 673. So this is going to be 673 minus 258.7, which comes out as 414.3. The next one is 11. It's going to be the absolute value 11, or not 11, 111. It's minus 258.7, which is 122.3. And then the next one is 21. So this would be 21 minus 258.7, which is 236.7. Okay, so if they were asking find the mean absolute value, and you just got to put it in the formula. You could use this, or you could use this. So it's going to be MAD So basically what you do is you add up all these numbers, 187, 167, 197, add them all up and divide it by the total numbers, which there's a total of 7. So it's going to be 180.7 plus 167.7 plus 197.3 plus 414.3 plus 147.7 plus 122.3 plus 236.7 all over 7. So your MAD is going to be 1466.7 over 7, which is 209.5. 209.5 is a fairly large number, right? What that means is the data values are very spread out. So this is your MAD. 205 is fairly large, so it's going to be, what that means is, that means data values are very spread out. So just note that the bigger the number, the more spread out the number. Okay, let's do one more for the mean absolute deviation. So this one says find the mean absolute deviation for 13, 15, 17, 18, 20, 12, 21, 10, 17. So it doesn't have to be in order. Just step 1, I'm going to find the average. So it's 13 plus 15, 17, 12, 21, plus 10, 17, all over 8. And that gives you 123 over 8, which is 15.375. Now we're going to make a table. It's going to be x, and then absolute value of x minus the average. So our first number is 13. So it's 13, and then absolute value of 13 minus the average, which is 15.375, which gives you 2.375. And then 15 would be 15 minus 15.375, and that spits out positive 0.375. 17 would be the absolute of 17 minus the average. Just make sure you're on track because it's easy to lose track. I get positive 1.625. Okay, 18. It'll be 18 minus 15.375, which spits out 2.625. the next one is 12. So it's 12 minus 15.375, which spits out 5.625. The next one is 21. Which spits out 5.625. I made a mistake on 12. It should be 3 point. On 12, it should be 3.375. And then on 10, it's going to be 10 minus 15.375, which is 5.375. And then the last one is 17. So it's 17 minus 15.375, which gives you 1.625. So the MAD is basically you add up all these numbers divided by total numbers, which is 8. So when I mean add up all of these numbers right here. So it's going to be 2.375 plus 0.375 plus 1.625. And then you divide that all by 8, and you get about 2.875. So 2.875 is pretty small. So what that means is it's smaller. That means the less spread out. Okay, so yeah, that wraps up for this section. I think the next section would be empirical, and we're going to stop here.